In addition to the Tunnel Talk greenhouse series, there's a series through OffCAF about alternative nutrient amendments. So I believe that there are 6 sessions in total, but I just sort of posted for the ones that are coming up in the next month. So sort of just an introduction, looking at compost, looking at nutrient amendments and soil interactions, and then sort of that conversion and creation of raw material to nutrient amendment. So that'll be awesome. I think they're all happening at 6:30 p.m. and you can find them on prenia.ca/learning. And before we dive in, we've officially launched a new service. So our plant health lab is now offering a plant parasitic nematode analysis following the 2-year sort of nematode project that we were working on in Nova Scotia. So if you're interested in that, check out the Prenia Plant Health Lab. So with that, we're going to jump to our feature presentation with Matthew Kleinhenz, and we're going to be talking about venting greenhouse environments and just generally talking about environmental control here. So if you want to take it away.
Sure. Hello everyone. It's great to be with you. I'm very honored, very pleased to have this opportunity. And from the very beginning, working with Talia has been truly fun and very, very smooth and efficient process. And I know that you're in very good hands with her and the rest of the team. I'm hoping that you can see the title slide and my audio and so forth are coming through okay?
Yeah, it all looks good.
Perfect. So yes, I was asked to address managing the environment, the internal environment of high tunnels with a specific emphasis on kind of minimizing these high spikes in temperature that we can experience in the summertime. So I'll focus on those as opposed to, say, heating during the wintertime, which would be perhaps a topic for another day. The presentation was discussed or presented at the Tunnel Talk webpage, kind of in the words that you're seeing here on the screen now, with a focus again on these high summertime temperatures and the inside the tunnel or perhaps outside the tunnel. So we'll focus on managing those environments using what we call ventilation status, or the positions of the doors, the end walls, and the vents. But I'm also going to comment on the role that other techniques and tools can play in this whole process. And there specifically, I'm going to mention films, covers, and fans as we go forward. I'd like to mention that I tend to use a lot of slides in my presentations. Most of the content on any one slide is picture, it's visual, it's not so much text. I'm trying to use those visuals as a way to reinforce or emphasize what I am saying. So if at any time you'd like some clarification, just ping me, and I will be glad to try to offer that. And of course, we do have some time left at the end of the presentation or the scheduled time together to discuss it as well. So we can always go back and retrace our steps as needed. So whether you're using the high tunnel mainly in the summertime, essentially from spring into the fall, or you're one of the few but growing number of growers, increasing number of growers who are using it essentially fall to spring, or using it entirely through the entire year, you appreciate that what you're doing is managing a structure that is influenced by the environment around it. We have essentially an open frame structure sitting on the ground. It is covered with a clear poly, and the wind blows, the sun shines or it doesn't, the wind blows or it doesn't, it is raining or it is not raining. The wind is coming from one direction or it's coming from another. It is a slight breeze, it is a heavy wind. All of these things are happening at once, or none of them are happening at all. The point that we really have to emphasize is that you have created an environment within that enclosure that responds to the environment around it, is actually shaped by the environment around it. So you are really aware of the constant fluxes of energy that are moving to and through the tunnel at all times, whether that be the soil or the air. Those fluxes of energy are always at work. I like to say to folks that the laws of nature, the laws of physics, chemistry, biology, one, they're undefeated. Two, they never stop. When we're sleeping, they're still at work. And so these fluxes of energy are essentially what we're trying to manage. So whether you are looking at, the sky conditions at your location, is it cloudy? Is it sunny? Is it raining? What is the temperature? Not only what is it now, but what was it before, and what is it likely to be, or what is it forecast to be? Or you're paying attention to the wind and what direction it is coming from, and exactly how, what is its speed. You're keenly aware of these three factors and others that shape the environment inside your tunnel. And I think it's fair to say that we are essentially farming inside a clear box. And we are doing that without the aid of active climate control systems like are used in climate control greenhouses. Remember, in a climate control greenhouse, we have options. There are options for that control that simply don't exist in most high tunnel ones. So that's our charge. That's our responsibility. That's the challenge that we've taken up. And so learning how to farm inside a clear box without the aid of control systems is a particular focus of today at the moment. So you ask, what are those external weather conditions? What is the ventilation status of my tunnel? More on that to come, but that's essentially how open is my tunnel. Plus other practices that you might be employing. Are you using shade cloth? Are you using low tunnels? Are you using mid tunnels? Are you using fabrics? These are also key to shaping the environment closest to your crop. All those together create those conditions that are really near the crop. The crop knows knows what it is, its environment is, what it's experiencing as a function of those external conditions, the ventilation status, and other factors. You add to that, what is the crop? Is it a cold loving crop? Is it a warm loving crop? Is it fruiting? Is it not fruiting? What have you? All those together determine the outcomes. And when you see that sequence, when you see the external weather conditions, how you manage the tunnel, what else you did or did not do inside the tunnel to shape the conditions near the crop, you know what crops you grew and what varieties you selected, and you see the outcomes. That creates a bit of a feedback loop that and it allows you to say, what will I do differently next time, or will I be sure to repeat what I've just done because it provided me with a high level of success. But that's the feedback loop that I personally have been experiencing for about 22, 23 years now with the high tunnels that I use on a daily basis. My team and I use on a daily basis in our work. And we have certainly learned some painful lessons through the years about this, and we continue to learn more. There are quite a few implications of those near crop conditions inside the tunnel. After all, we can look at the disease triangle, for example, and ask, well, is the environment conducive to the development and progression of disease? We can assume that we have the pathogen. Maybe we even have a susceptible host, but disease is less likely if the environment doesn't support it. So what are we doing as a grower, for example, to reduce the likelihood that disease will start and progress? We can also ask, just what is the absolute temperature, and how is that affecting the crops inside my tunnel? After all, they, like us and other animals and other beings, they respond to their nearby conditions, just to flat out response to, is it in their temperature optima, or is it not inside their temperature optima, the range thereof, right? So we can deactivate tomato pollen if the tunnel gets too hot, and X number of weeks later we will have a dip in yield. And we say, well, what happened? Why is my yield this week lower than it was before? Well, go back 3 weeks, and did you have 2 or 3 straight days, or even at the 1 straight day at a temperature that was probably very damaging to the pollen, and you had less fruit set? These are examples of heat damage of vegetables, among others. So collectively, we know that we're working in an environment that is shaped by the conditions around it and inside of it. And as high tunnel growers, we're kind of asked to learn how to manage all of that on the fly, on the job. There is, as I'll say here in just a moment, no do-it-yourself guide to say, do this, do this, do this, do this, do this. And this is all sort of taken as a given that high tunnel growers will have to learn on the job through trial and error how to manage the environments inside the high tunnels. And this is no small factor, I would say. We have that is in direct, I say not opposition, but that is very different from other aspects of our production scheme and our management schemes that for which we do have very direct and clear resources that can guide us through, say, crop protection as an example. The team at Purdue University in Indiana took a look at this challenge and many others when they worked with a lot of growers who use high tunnels, did a lot of, let's say, survey here and a fair amount of interviews, and they did conclude this is a very, very comprehensive treatment of the subject. And they were very clear about some of the challenges associated with high tunnel production that extend well beyond the ones that get a lot of press and a lot of attention. And just some of them included this: how do I manage the internal environment, and how do I do that and still have a life and get other tasks done in my business? Because as some of us know, we can find ourselves kind of babysitting the tunnel at different times of year. As I mentioned before, there is no recipe for this. There is no formula or do-it-yourself how-to guide on exactly how to manage the tunnel environment, because, as we will see here in just a few moments, and you can probably guess or know firsthand already, that the tunnel on your property, or even one or more tunnels on your property, all behave slightly differently. You have to get to know their personalities, their nuances, if you will, with regard to how they respond to the environment around them. There are no resources, no guides, but occasionally you'll see articles like this one. This is taken directly from a large circular that I receive, and you might know of as well. Look carefully at the picture and the 10 factors that are listed there on the slide. Look really carefully at that picture and then the 10 captions. And you'll see that some of the captions literally don't apply whatsoever to the system that is represented with the picture. So in this case, that tunnel doesn't look like it has electricity, so heat mats are probably not an option. A wet wall method, that's essentially fan and pad cooling. There is no fan and pad cooling in this high tunnel. You can use shared curtains, of course. Horizontal airflow fans, which we will talk about, are an option, but they don't seem to be present. HVAC system, there is none in this particular tunnel. Smart controllers, there don't appear to be any. So this is a perspective that's coming very much from the climate control greenhouse point of view, but it's a picture that is representing a high tunnel, or some people would call a solar greenhouse, and some of that simply doesn't apply. So again, there's a disconnect between the picture and the caption, if you will. Still, some folks in the research extension space, and of course in the private industry space, are doing a very good job of assisting people in knowing how to manage the environments inside their tunnel, such as this person from Joe Hannon from Iowa State. Again, no recipe or formula, but there are very good principles and tools and techniques, and a lot of what I'd call weighted observations or trends. Again, nothing ratified, if you will, by the majority in a formal sense, but somewhat taken as reliable. And these are the ones that I would like to focus on for the remainder of our prepared comments, and perhaps some questions after. So I'll talk about the ventilation status first, then speak to the use of different films and different covers for the high tunnel, and fans if that is an option for you if there's electricity at the tunnel. The ventilation status is essentially how open is the tunnel. This tunnel back here, and the ones that you'll see coming up, they have sidewalls and they have end walls, and both of them can be open. So the ventilation status is asking, how open are they relative to the volume of the tunnel and relative to their maximum value for being open. just how much surface area is exposed to the outside relative to what could be exposed. And this is an incredibly important factor because when you consider the sunlight is the actual source of energy in all of this, primary source of energy. Of course, the air temperature does matter as well. But then we have the wind speed and wind direction. And depending on how open that tunnel is and where the wind speed, where the wind is coming from and how hard it is blowing, that will certainly determine how much air exchange occurs between the outside and the inside. And that is a key factor, as we have seen in our work over the, 20 plus years, but very formally in the last 2.5, where we have 10 high tunnels, 7 of which are oriented north-south, 3 of which are oriented east-west with their long axis in those 2 compass directions. And we've been studying them around the clock for two plus years and carefully noting the ventilation status at all times as we manage them. So in this case, we've taken each sidewall and each end wall, and we've asked, is it open 0%, 25, 50, 75, or 100%? We know what the status is at all times for both the sidewalls and the end walls, and all 4 of them at the same time. So we know exactly what the configuration is. And we also monitor the external conditions, the sunlight, the temperature, the wind speed, and the wind direction. And so we're essentially aligning our ventilation status measurements with over 130 other variables every 5 minutes. And that's been going on for 2+ years. So we have, or possibly, well, an exceptionally large data set, possibly the only one of its kind that I know of, that can link external air conditions, ventilation status, and internal conditions of these particular 10 tunnels. And what we see when we look at some of the data, and you can, in just a moment, I'll show you where you can see all this data as well and use them, is that there can be subtle but possibly important patterns along, with some very obvious trends. This happened to just be 1 week ago, a little bit more than 1 week ago. Each line that you're seeing is the temperature profile for a different tunnel. The black line is the outside air temperature. So whenever you see separation in the colored lines, that means that it's the ventilation status of that particular tunnel allowed it to be different from, allowed the temperature inside of it to be different for another tunnel. Each time you can see separation in color, you see what the possible effects are of a particular ventilation status. And we won't dwell too long on these numbers here this morning. I simply want to emphasize that these are 10 tunnels at the same place, experiencing the same weather, 7 of which have north-south orientation, 3 have east-west orientation, and 7 are of the same size, 3 are also of the same size, but larger. And so the primary difference between them or among those tunnels will be their ventilation status at any one time. So any time that you see it separating from another tunnel in terms of its inside temperature, it is probably a result of the ventilation status that is in place. Say, well, we get a spread of about 6 degrees to 9 degrees or 14 degrees at different times in terms of maximum temperatures. On this particular day, another day when you see the spread, even perhaps a little bit more dramatically so, a spread of 9 degrees in one case or 8 degrees in another case, but a range across the tunnels of 7 degrees or more. And in this case, also when the temperature reached closer to 32°C, we had a differential of 8 degrees. So when one temperature was 32, another one was 28 or lower. You might say, what's the difference between 4 and 5 degrees centigrade? The difference between 4 and 5 degrees centigrade, again, for some biological reasons, can mean the difference between pollination or no pollination. It can mean the difference between being able to irrigate 6 hours to 8 hours later or needing to irrigate earlier. It can have different effects on a cumulative or even an acute basis. I went through those slides rather quickly, but I want to emphasize that all of this information is available at this one website here. there's a bit of a decision support dashboard where you can see in real time the ventilation statuses of our tunnels and the temperatures inside of them. And if you choose to, you can go to the second resource and say, okay, my forecast is partly cloudy, about 25 degrees C, wind from the east or the north southwest at 10 or 18 miles an hour. What are the ventilation statuses that have been recorded? And I want a temperature inside the tunnel of 27 C. What are the ventilation statuses that have been recorded in Ohio that allowed those conditions to be possible? That were true under those conditions. That's how that resource works. It allows you to essentially plumb all of the data that we have collected for the past 2 years for your own benefit. You will obviously need to ground truth that for your location, but it may remove some of the guesswork for you and when you are choosing to set a ventilation status. So again, we know that most of the ventilation is accomplished via these vents, which we have discussed, but the end wall doors and sidewalls. And when that capacity is utilized, when it is, for how long it's in place, this all matters. This will all accumulate for you going forward. Here we have examples of high tunnels at the University of Tennessee. You'll notice those large end wall vents above the doors. This picture was taken at U.S. New England. You see the very long ridge vent that goes along the top of that tunnel, which is very, very effective, but also a little bit on the costly side, but it is very, very effective. This is a really, really interesting design that I saw in Tanzania. It's actually, I think, Danish in origin. It's essentially a high tunnel with two roofs. Top roof is plastic. The lower roof is screening, so the entire roof is vented. But the water, the rainfall is kept from going in, which I find to be really, really novel. So I'm trying to work with an engineer here that will allow me to raise and lower that top roof. So when I want to close it, I want to close. When I want to open, I want to open. And that should be possible with a hand crank, geared system, I would like to think. But again, the innovation in the space should continue. Some really interesting approaches that I saw in Kenya, where people use wiggle wire to great effect. And in the rainy season, the plastic is in place. And when it's not the rainy season and warmer, the plastic comes out and the screen goes in. And essentially, the whole high tunnel becomes, well, a large part of the high tunnel becomes ventilation capable. Even though it's not opening and closing, it's essentially always vented, as you can see here through the screen. It also keeps the wildlife out and some of the insects as well. So another very, very interesting approach. One final comment before we move on to another aspect of another option that you have is something we here call knee walls. And you're looking at a 21 by 48 foot long high tunnel in Worcester. It's clearly the fall or springtime, snow on the ground. And this is a time for us when we would like to establish or maintain a number of crops in the tunnel, but also need to ventilate it occasionally. Occasionally, we have actual sun during this period of time, as you know, and it can warm up. It can reach temperatures that we actually don't want. So how do we use a roll up to open sidewall when in the springtime our seedlings are very low, or in the fall time we're trying to keep say our leafy vegetables very, very happy? What we do is install a row of wiggle wire track roughly halfway up the sidewall, and in the fall time we put plastic in that section so that when we roll up the sidewall, the only way that it vents is from above that piece of plastic, which is higher. So as the air comes in, it kind of mixes with the warmer air inside before it settles to the ground. And it keeps the wind off of the seedlings, and it allows the air to mix a bit before it actually reaches the plant. So we found this to be very, very effective. So it gives us an option to control ventilation in that spring and summer period to a much greater degree than we are able without that new wall. So when the sunlight and external air temperatures are maximal, the tunnel is likely to be fully open. You're likely to have it as open as possible. What else can you do to reduce the temperature? That's a big question for part of the remainder of today. And one aspect that you could consider is using an alternative film. There are films available that have additives to them that reduce the amount of incoming radiation, but not to a degree that affects the crops, but and their effect is to keep the temperature 2 to 4 degrees cooler inside the tunnel than outside the tunnel. One product name was Solar Ice. That's the name that it went by when I tested it. I think it's going by a different trade name now, but it definitely worked as advertised. When we had this covering one of our tunnels, that tunnel was 2 to 4 degrees, consistently 2 to 4 degrees cooler inside than outside. It was kind of certainly an unexpected result from the standpoint of traditional experience, but not when you consider the laws of physics and how they apply here. So that, I think, is going by a different trade name now, but it does work. The trick is, do you want that to be true at other times as well, when you would rather have the temperature be warm. So if you're mainly a summertime grower and you're always battling high temperatures in the summer, one of these types of films might be a viable option for you. Additionally, you're probably aware of covers and the use of shade cloths that are at different weaves and reduce the amount of incoming light, at least penetrating the plastic from the outside, anywhere from 30 to 60 or maybe even higher percentages, and they come in different colors. And also they can be embossed or not, but these are very, very effective when applied to a tunnel. They can be applied separately, of course, put on and taken off. And they work exactly as advertised. They create shade in the tunnel, and that shading creates a lower temperature. And again, if you can choose the right one and apply it at the right time and use it with the right crops, it can work to great advantage. It will keep the tunnel cooler than it would otherwise be. And so on farms, you see shaded and unshaded tunnels, depending on what's being grown in them. And you also see different tunnels covered with different levels of the shading material itself, 30 to 60%. They may actually shade one end of the tunnel with 30 and another end with 60, or one tunnel with 30 and another one with 60. It's a mix and match kind of scenario where you can use the one you need exactly. And as I was chatting with Talia right before we started, there is a group working at the University of Georgia who took a look at the combination of factors that you see here in the title of their paper. They wanted to ask how does shading and fogging affect high tunnel production and the crops that are grown inside of it. And this is some of what they've reported. You can see this information available for online. But the shading and the fogging did, as predicted, reduce the temperatures inside the tunnel. And it did not always affect yield, but in the case of fogging, which is where I want to focus on at the moment, in the case of fogging, it did increase leaf wetness, which from a pathology point of view is rarely desirable. And so it's just something to keep in mind. And again, it's kind of moving the high tunnel system closer to a climate controlled greenhouse one, in which we have can have fan and pad cooling options available to us. So what factors usually come into play when you're thinking about shading? Well, what crops are you growing? Are they cool season, warm season? Are they both? How do your plants, or how will your plants respond to shading? Light and temperature responses can be crop specific, and some in a very positive way for the grower, and some in a not so positive way. What level of shade will you create, and when will you put it on, and when will you take it off? And does it have any impact on the plastic? Sometimes it can be slightly abrasive if it's loose. You'll just want to pay attention to attaching it well, so it is not damaging the plastic that's beneath it and aging it prematurely. But again, shading is long known to be, in certain areas anyway, very, very effective at reducing temperatures inside the tunnel. At the same time, it reduces light. And as I mentioned, the embossed versions tend to be perhaps even the most effective because they're not only reflecting light back out, but they're also preventing it from coming through. So silverized, and as you would expect, more expensive. So as I mentioned, you will see in this particular image, you see two high tunnels with ridge vents in the lower right. So they have that ridge vent going down the entire spine of the tunnel, allowing hot air to escape. One tunnel is also partially shaded. And the tunnel on the lower left has the embossed or the type of shade cloth, which is both preventing light from coming through, but also reflecting it back. And in the upper left, you see tunnels that are shaded and not shaded. Again, exemplifying that practice that in one case, I want the shade, and in another case, I don't want the shade. And that of course applies to folks who are using more than one structure. And this is from Claire Coleman, Elliot Coleman's daughter. And again, just another low res image, but very effective one of showing shading on one side of the tunnel and a ridge vent at the same time, and how that can create microenvironments within the tunnel that are working to their advantage. And finally, with regard to covers, there is the spray-on shade, or not only is a product like this liquid shade, or a do-it-yourself recipe that you can put on the plastic. The very, very effective, again, because it reflects and it shades. A challenge associated with that is it stays on until it washes off. The application can be, well, as you can see here, it needs to be sprayed on, or people just take buckets and they throw it up on the tunnel and let it run down, and it just keeps covering. Again, it gets the job done, but it will stay in place until it is washed off. And so it's just the same question with the shade cloth. When do I put it on, and how thickly do I put it on? And when I want it to go away, will it be gone? You might find yourself needing to create rain if you don't get enough of it to wash it off. Finally, internal air movement with fans, either with or without misting. There's no doubt that moving air into and through the tunnel and out can be a real advantage. Typically, that requires electricity. Many of our high tunnels are not electrified or don't have a source of electricity, although that is changing, especially with the opportunity to use solar power. We can position solar panels right next to our high tunnel and run small fans from the solar panels directly. This is something that we are experimenting with. We're also using that same solar power to power motors that control our sidewalls. But anyway, in the focus on ventilation, there's little question that moving air into and through and out of the tunnel can really help in multiple ways, exchanging not only cooler air for warmer air, but also drier air for more humid air. And the rules, the basic rules apply here, where usually it's circulating around and out. So you might have two fans blowing one direction, another two fans blowing another, the opposite direction, slightly angled downward to stir the air, to keep it mixed, to keep the temperature as low as possible and the humidity as low as possible. And you simply need to utilize fans that are large enough for the space that you're trying to move air through, or enough fans of a smaller size to do the same job. But it definitely offers an improvement. When you couple that with fogging, you are creating the opportunity for a bit of evaporative cooling, because you're humidifying the air. The humid air will pass through the crop or around the crop. Heat will be exchanged. Evaporation will take place. The crop will cool itself, and that warm, moist air will be exited outside the tunnel. If all of that can be achieved without creating conditions that are ripe for disease, so much the better. It simply means that it takes more to manage to make sure that it remains an advantage and does not become a disadvantage. But clearly, climate control systems have shown very well that fan and pad or wet wall method, whatever it's described as in your area, that evaporative cooling does work. It's just a question of, in a high tunnel system, can it be made to work completely for the grower and not for them, and not against them in any way. Because what we don't want, of course, is like Talia and I were discussing before, in the effort of solving one problem, we create a much larger one, and that's not what we want. So in the attempt to reduce the temperature, we do not want to create a tremendous amount of disease, for example, is our mission. So in summary, I'd like to thank you all for your attention and open the floor to questions, and simply say that the management of the environment inside the tunnel is one key factor in your success with utilizing it, because it's the abiotic conditions, temperature among them, that shape your cropping outcomes. And you, as the high tunnel user, have influence over those conditions, and including the temperature, through your ventilation practices. And I'll stop by encouraging you to consider the principles or the information that you use in choosing a ventilation status at any one time. I'm well aware that some people live very close to their high tunnels and they can manage them more actively than others who do not have as much access to the tunnels. And it's not always about physical distance. It's very much about time as well. Some people are set it and forget it managers, if you will. I only have 1 or 2 options per day to set the ventilation status, and they have to make the most out of those 2 actions. I'm simply encouraging you to examine your ventilation practices, your ventilation options, and ask if they're working completely in your favor. And if you're not comfortable with the answer, ask again what can be modified slightly to make that ventilation status work more in your favor. I would be very happy to address questions that you might have. And this is a way to contact me. I would be thrilled to hear from you going forward. But if there are any questions now, I'll be glad to try to address them. I'll keep the share going in case we have to go back to visuals. Otherwise, I can take it off, and we can talk face to face.
No, I think that's great to hold that up. Thanks so much.
Yeah.
A lot of good stuff covered. Okay, I have a few questions, and anyone feel free to interrupt me at any time if you want to cut in. So you mentioned that you're doing this work looking at the different percentage ventilation and walls open. Is that something you're going to be continuing into the future, or like what are some of the other things that you're working on in this space right now?
We want to continue that into the future, and what we want very much to do is involve other sites.
Okay. Yep.
Because we realize that a high tunnel in Worcester, Ohio, at roughly 42 degrees latitude, with our particular site, it does not represent everyone's by any means. We've long been, comfortable with or aware of that reality. What we're trying to identify are the principles, test the principles that we think are at work that at every high tunnel.
Mm-hmm.
So, number one, we will continue it here because the response to it has been fairly positive as people learn a little bit more about it. So, for example, when people come to visit and they may be working, say, with only 1 high tunnel on their property, or maybe 2, but certainly in many cases just 1. We walk from each of these tunnels to another, and you can do that, in 5 to 10 minutes, depending on how long you linger in any one tunnel. And so they literally can walk into one tunnel and they say, "Oh, it feels this way." They walk 80 feet and they go into another tunnel, and it feels entirely different.
Mm-hmm.
And you see this look come over their face, like they say, I would have never known this. I would have never known that an 8-inch or 10-inch difference in my sidewall height would have mattered. Or I would have never known that if I open the south doors when the wind is from the north, but I keep the north doors closed, that I could still get some reduction in air temperature. I thought I needed to move air through. It helps. But if I just want to cool a little bit, the siphoning action of the passing wind will actually pull air out of the tunnel. So they begin to appreciate the options that they have, I think, a little bit more fully. So,
Yeah,
so Talia, I'd like to, we in our dream, we would like to essentially have this dashboard created with tunnels from various locations, so people could have more local representation for themselves.
yeah, I think having those spaces on site and being able to walk from one to the other is incredibly impactful. You can't argue with that, right? Um, so we'll kind of switch gears here. Okay, just kidding, we're not. Have you done this sort of work and also played around with like things like shade cloth?
We have not used shade cloth in our experiments to date. We at our research site, we have worked with growers who do, who have. So, for example, we worked with a grower who has two high tunnels. They're very close to each other. They have the same compass orientation, and we had a long conversation around the experiment he would like to do. So he shaded one tunnel and he didn't shade another tunnel, and we outfitted him with data loggers that recorded temperatures, and then we sent him the data, and he was absolutely stunned. I mean, he knew that there was a difference in temperature. He could feel that. He didn't need our data to show them that. But what he was not aware of is exactly how warm the unshaded tunnel got and for how long. So we personally have not experimented with shade cloth at our site. We tend to do more experiments involving changes inside the high tunnel. So we leave the cover. We don't modify the covering of the tunnel itself. But what we will do are use our fabrics or shade cloth inside the tunnel.
Yep.
Those are, I think, productive for us from the standpoint of being able to create what we call microenvironments or smaller environments in the tunnel that are different. And as predicted, they work just like you would expect at some level. If the whole tunnel was covered with shade cloth, we can create a zone in the tunnel that's cooler than another zone in the tunnel. So, or obviously more shaded, as an example, or the opposite, warmer as well. We can definitely create a warmer zone in the tunnel than in other ones.
So on that note, then, do you have any experience with vertical circulation fans as opposed to horizontal ones?
Great question. I do not, and that's something that we should look more carefully at. All the fans that I've seen and what I was talking about before, they're circulating more or less horizontally with a slight angle, but I have not yet tried ones that are either pulling and pushing up against the roof, and so it would fall down, or the opposite, pushing down from the top and it would hit the floor and dissipate from there. So I have not done that. So that's something that's very exciting.
Yes, it is. Okay, so then I guess similar along the lines of the shade cloth, you guys probably haven't played around with different types of plastics either then, correct?
Well, we have one of the 10 tunnels is a double layer.
Okay.
So not a different kind of plastic, but 2 layers. In the past, again, we experimented with the product I mentioned before, which reduced the temperature inside the tunnel. We're also working with a local supplier who has created, actually, it's right here, a film that will last 10 years and is far more tear puncture resistant than the standard poly film. So we do experiment with films as often as we can because I think innovation in that space is still very much needed. The challenge with it is that the standard 6 mil poly clear poly film is so ubiquitous, so common, and so familiar to people that they think it's perhaps the only thing that's worth investing in or will work. So it can be difficult to get a lot of innovation in that space, but I do think more of it is needed, for sure.
I have one other question about, so it's not fogging, but sometimes you'll see like wetting the outside of a space to try and reduce the temperature. Do you have experience with that? What do you think?
This would be wetting an area outside the tunnel in the hopes of cooling it inside.
Yeah, so I think sometimes you'll see it in like more high-tech glass houses where they have sprinklers on the roofs. But whether, yeah, have you seen that in sort of a high tunnel space, or does that just not?
I have not seen that in a high tunnel space. I do have, what I can say is if you, and this is not novel, we have a number of our tunnels that have an overhead irrigation system in them. With drop nozzles. We can make it rain in our tunnel, and every time we do make it rain, it cools it down. You can see it immediately. The moment we flip on irrigation, 2 to 3 minutes later, the whole tunnel is cooler. And in part because the water is cooler, and of course it's humidifying the air and it's being exchanged. The moment that the irrigation goes off and the humidity spikes up to maximum is when we start to lose some of that cooling effect. We have not tried that same principle by wetting down, say, the roof of the tunnel and seeing if that changes the conditions inside. It's an interesting idea. I wonder if it would work with clear poly. In general, we're trying to create, I think one thing that comes to my mind, Talia, in that is the high-tech greenhouses would probably have a very sophisticated drainage system. And because of course they have to dissipate rainwater and the like. And I'm just not sure if everyone does with a high tunnel system. And
Well,
so
it might just rain
I-
right into the side vents.
I would worry about water intruding in the tunnel.
Yeah.
That's being used to cool it.
Yeah. No, and that's not, I haven't seen really that being implemented anywhere, but I have seen it noted in papers or articles or something. So yeah, I was curious whether that was either, cutting edge new stuff or something we've already kind of written off a little bit.
I don't know if I personally would say I wouldn't have written it off. I wouldn't have even experimented with. I don't know anybody who has, but it's just, it's one of those, I think, steps that makes very much, or could make very much sense for the system for which it is designed. And if it's applied somewhere else, it would have to be modified, or that system would have to be modified to accommodate it. And yeah, so if you have gutters on your tunnel and you can recirculate the water, certainly prevent it from going into the tunnel, it may be worth a try. It's just that most people, I think, are not in that particular situation.
Yeah, no, absolutely. So okay, so we talked about venting. In terms of what vents you think are non-negotiable. So we talked a lot about side vents, but what about end wall?
Yeah, I'm looking for a good picture. Should probably get. I would say end wall vents are largely one of the best investments one can make. For the return on investment can be great. I see that I cropped them out of my high tunnels, but I showed, oh, here's one. Are you seeing this picture by any chance?
No, we're
Okay,
seeing
let
a
me
nice
stop the
backdrop.
share. Yeah, let's stop the share and then restart it. How about that one?
Yes.
Okay, yeah, that's just a little bit. So this is one of our tunnels with an undersized end wall vent, okay? You can see that it's framed for one that's bigger, but at the time that we installed it, we simply didn't have access to it. It's my personal opinion that the end wall vents can provide enough ventilation under certain conditions that the tunnel can otherwise be closed or open minimally at our location. I have seen in spring and fall days where the tunnel was either completely closed or the one end wall door was open just literally like a crack to allow air to enter. and the end wall vents were open maximal, and the conditions in the tunnel were perfect.
Hmm.
This particular tunnel that you're looking at is on the left is 30 by 80 feet. And so I tend to think that end wall vents are probably one of the most cost-effective investments that one could make. And at least in the environments with which I am familiar, okay? Because they can offer ventilation that would otherwise not be possible. And
Yeah.
the heat rises, and if it can escape from where it is, then more effectively, then it's better.
Okay, awesome.
Yeah.
It's good to know. So you talked a bit, like, obviously you guys are monitoring the outdoor temperature in your trials. Do you think it's important for indoor growers to also have sort of this outdoor climate data as well as the inside to help make their decisions?
A great question. I've had hours upon hours of conversation with lots of growers over the years on this very topic. And I appreciate that some of us are more data oriented than others. Some of us are more numbers oriented than others, if you will, where we look to numbers in some way. I think that some numbers can go a long way.
Mm-hmm.
And I think that there's always pen and paper, but there is also inexpensive and very accessible technology to help create some numbers. I tend to think that some numbers can be very, very informative. Obviously, they can misinform too. One can be misled by just the extremes, right? That last for 5 or 10 minutes and say, "Oh no." But yes, I do think that being cognizant of, being aware of, and maybe even having some record of the conditions outside the tunnel can help a grower over the long run. They will be more effective at troubleshooting. They will be more effective at understanding that feedback loop between what the decisions that they made, the external environment, the internal environment, the outcomes that they had. They will have more information to go on when they're trying to determine what happened.
Mm-hmm.
And I'll just own it. I cannot trust my memory for such things. I don't have an encyclopedic memory of what the temperature was on June 10th at 2 o'clock in the afternoon to 7 o'clock in the evening. It's not something I want to have to remember, so I can always just look it up. And it actually helps. It helps me understand, what was going on.
And I think, yeah, to your point where, we're trying to assess how impactful our interventions are, whether it's new fans or venting strategies or
Right.
shade cloth, that's really the only comparison that
Right.
we're
Right.
able to do.
Yeah, and we started with this I'll say a slow way. We started with putting data loggers in all of our tunnels, and for years upon years, we never had the data until we downloaded them, and it was weeks, months later that we examined it. Like it was always in the past.
Mm-hmm.
Only more recently, in the last 5 years, did we go to the real-time reporting approach where we can see a data point literally 10 minutes after it's been registered. So, and that has a distinctly different power, if you will. But I would never give up even the retrospective look on the data, like I was talking about with the one grower. He didn't have to go through the 5,000, 10,000 data points that we gave him, every single one of them. The whole point was to identify those times when he thought he had a problem, and sure enough, he did.
Mm-hmm.
He was able to troubleshoot more effectively what had happened, in part because of the logs that he had created. So yeah, I do think that being aware of the numbers can help. But again, I'm a numbers guy, and so I have to understand and appreciate that.
Okay, and so
I get asked all the time, actually, and
yeah,
people are more and more interested in it. And since the technology is available and accessible, I think more and more people are headed that direction at some level.
and so on that final point, do you have any sort of more real-time sensors or sensing technology that you would recommend, or what you've liked in the past?
Yes, and this is something that maybe I can follow up with you by email about, and then you can fire it out to people. Because this is a question that I should be able to rattle off names and so on, but I'm not gonna do that here. What I can do is I can send you some information that you could then share, because this question has come up several times in the last 2 months with other growers that I'm working with, one of whom produces seed in her high tunnel. So she says, I have one bad day, I could literally have no crop. So she's been very keen to at a very strict budget, identify ways in which she could monitor the conditions inside her tunnel and her drying spaces.
Mhm.
So I'd be glad to share with you what I've learned through that process of kind of looking widely for that. But one of the challenges with this real-time reporting is it needs a Wi-Fi or a Bluetooth connection.
Yeah.
Which, again, we could have a whole separate discussion about. I'd be happy to do that. It's not as difficult as one would think. Even in places where the network connection can be spotty, right? There are still options that one has, if they're not aware of them, that they can get their own little system where, 500 meters from the 200 meters from the house to the high tunnel, you can still get a report from it, right? You may already have some of that in your farms and businesses, the so-called smart home technology kind of stuff. But yeah, I'll send you an email. We can keep the conversation going.
No, that's perfect. So yeah, thank you so much for your time today, Matt. That was a lot of great information and really just highlights the power of, tools that we can use in the space to modify the space in a significant way. And that, we know that that can have a big impact on the quality of our crop and yield overall. So yeah, thank you everybody for coming. I will follow up with an email with the recording and then some additional resources from Matthew's presentation, and then sort of that sensor information as well. So thank you guys so much and enjoy your day.
Thank you, everyone. Take care.
Bye.
Bye.